So hello friends, in this lecture we will discuss about the most important topic which is commonly used in operating system, that is scheduling, preemptive scheduling. Before going through this preemptive scheduling, we should know what is a process, because process plays an important role in any type of scheduling, right? So what is process? Process is basically a program in execution. Or in another words, we can say that whenever program is executed, this is basically known as a process, right? So any process may occur in four states. Number one is called new. Number two is called active. Number three is called waiting. And number four is called halted. It is also known as a termination, right? This active state is basically divided into two main parts. Number one is called ready and number two is called running. So let us understand this with the help of a figure. We have a state which is called new. We have a state which is called ready. We have a state which is called running. And finally, we will have a state which is called halted. So we must have one more state which is known as waiting. This is to be there. So what is preemptive scheduling and what is non-preemptive scheduling? It is basically depends upon this state diagram of a process. So number one, when a process is switches from running state to waiting state, this is number one. It means we are requesting for input output, means the input from the keyboard and output onto the screen, right? Second, when a process is switching from running state to ready state, it means there may exist an interrupt in between the process. And third, when a process switches from waiting state to ready state. And finally, when the process terminates or halted. So, point number one and point number four, when occurs. It means when a process switches from running state to waiting state or a process halted. This circumstances is basically known as non-preemptive scheduling. We have already discussed it in last lecture, example based on this. In this lecture, we will discuss about the preemptive. The rest one means second and third, in which process is waiting, switches from running state to from running state to ready state, number two, or from waiting state to ready state. So these circumstances are basically known as a preemptive scheduling. Let us discuss this with the help of an example. Suppose we have three processes: process P1, process P2, and process P3. The arrival time of each process is given to you, that is in milliseconds. Burst time is also given to you, that is in milliseconds. Burst time is also known as execution time, right? So this is also known as execution time. Now, we'll represent how the process stays in a queue with the help of a chart, and that chart is known as Gantt chart. So this chart may have a rectangular box, right? In a rectangular box, what we have processes P1, P2 and P3 respectively. Now, process P1 arrives first. This is process P1. When process P1 arrives, the waiting time of process P1 was 0 milliseconds, right? Now, next process after P1 is process P2. Now here it is important to note that the new process is process P2. The execution time of this process P2 is 3 milliseconds, which is less than the execution time of process P1, means the remaining execution time. So remaining execution time for process P1 is 6 minus 1, that is 5 milliseconds. So this is the current process, new process is P2. If In another words, I can say that the execution time of current process is greater than or larger than the execution time of a new process, then that process should be preempted. Preempted means taken out, and it will be used later on. So it means process P1 will be taken out and process P2 will be scheduled. This is to be there. And the waiting time for process P2 is 1 millisecond, because after 1 millisecond process P2 enters into the queue. Right? Now next, we'll check the burst time or execution time, all the processes that remains in queue. So we have already used process P1, and this process P1 is preempted and it will be used somewhere else in a memory or in a queue. So what we have, the next process is process P3, and after process P3 we'll check the shortest execution time. After 3 the shortest execution time is 5 and then 7. So it should be like this, 3, 5 and 7. So what we are trying to use, we are using a shortest remaining time first process. So the next process will be in memory is P1. Now what will be the waiting time for process P1? It should be 1 process P2 and its execution time 3. That should be 4. Process P1 waiting time is 1 and its execution time is 3. So 1 plus 3, that should be 4. And the last process that should be available in ready queue is process P3. Right? So what will be the waiting time for process P2? It will be the average, it should be the waiting time of process P1 4 plus the execution time of process P1, which is 5 milliseconds, because 1 millisecond it has been already printed out. So it should be 9, and the total execution time for process P1, P2 and P3 is 16. So here what we have, 60 milliseconds. Right? Now what is our main aim? Our main aim is to find out the average waiting time and average turnaround time. So average waiting time, as we have already discussed earlier, should be the waiting time for process P1, P2 and P3 divided by number of processes. Right? So what is the waiting time for process P1? The process P1 waiting time is 4, and after 1 second it arrives, it means 4 minus 1 plus what will be the waiting time for process P2? It should be 1, and its arrival time, that is 1. It is 1 minus 1 plus what will be the waiting time for process P3? It should be 9, and the arrival time for process P2, it means 9 minus 2 divided by 3. So we get the result, it should be like something like 3.3 ms milliseconds. This is about average waiting time. Now next is what should be the average turnaround time. This is the last point in it. So that should be in this format, average turnaround time. So turnaround time is when the process completes its job to the process submit into the memory, right? So turnaround time, process P1 completed its job in 9 milliseconds. So it should be 9 minus the arrival time for process P1 is 0 plus second for process P2 the completion time is 4 millisecond minus its arrival time, that should be 4 minus 1 plus finally for process P3 the turnaround time is 16 minus its arrival time, that is 2 divided by number of processes 3. So that should be something like 8.6 milliseconds. I hope you are able to understand this concept. Thank you so much for this lecture. In the next lecture we will discuss about priority scheduling. Thank you so much.